Hello everyone, welcome again. From the previous video, we talked about static friction and we evaluate the maximum of friction needed in order for the box to start moving. We applied initially 200 newtons and we knew that the Fs max, which is the maximum static friction needed, was 235. So that means we need to apply at least 236 for the box to start moving in order to overcome the static friction. Now in this problem, what I decided to do is do the kind of a similar problem, but in this case, in this problem we'll be dealing with kinetic friction. Now let's say we have the same box, 30 kilograms. Now we have a mu k of 0.6 and you have an applied force of 300 newtons moving to the right. Just as a note, mu s will always be greater than mu k, always. So now our applied force is moving to the right, so F equals to 300 newtons. So since we are moving to the right, we know that the static friction will be moving to the left. So our static friction our kinetic friction will be moving to the left, right? Since we're dealing with motion, we know that the box is moving this time, then the static friction will be replaced with kinetic friction. Now the question is, we need to evaluate, so find the kinetic friction and then also find the acceleration of the box. Okay, now since we have the force moving to the right and then we have Fk moving to the left, and we know that Fk, so we can easily find that we know that Fk equals to mu k times n, the normal force. So let's go ahead and put our forces. So we have the weight, which is mg, and n, which is the normal force moving up. Now we know that this box is not accelerating up and down, right? So we know that the acceleration is 0, so the net force is 0 on the y-axis. So which means that n minus mg equals to 0, which means that n equals to mg. Now Fk equals to mu k times n equals to mg, so mu k times mg. Now what is mu k? Mu k, we have it as 0.6 times mass is 30 kilograms times the acceleration of gravity, which is 9.8. So this will be, so 0.6 times 30 times 9.8. So give us 176.4. 176.4 newtons, right? So this is the kinetic friction. It will be this one. Now we want to find the acceleration. We know that from Newton's second law that F net equals to ma. Now in what direction will the box be moving? It's moving to the right. Since it's moving to the right, we know that acceleration will be in this direction. So then F, which is the applied force, minus Fk equals to ma. This will be our net force, right? So the force of motion minus the opposing force Fk equals to ma. We know F, we know Fk, so we're gonna find A. So this means A equals to F minus Fk divided by m. What is F? F is given to be 300 newtons minus the Fk, which we found to be 176.4 newtons, divided by mass. The mass of the box is 30 kilograms. So acceleration will be, let's go ahead and evaluate this. So 300 minus 176.4, which is 123. So 123.6 divided by 30 kilograms. So divided by 30 kilograms, and this would give us 4.12 Newton per kilogram as acceleration, or we can say, you know, the unit can also be 4.12 meters per second squared, same thing, right? So, and that's it for our problem. So I can put it here. So A is 4.12 meters per second squared. And that's it for this problem. If you have any questions, and if you have a very particular problem that you would like me to solve, please leave it in the comment section. I'll be more than happy to do so. As always, thank you for watching, and I will see you in the next lessons.